Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, let's have a look at this algebra question from Leaving Cert Ordinary Level 2014. So this was on a sample paper, and then I tend to expect the sample paper questions to be just a tad harder, same with a mock question. Part A, solve the equation x squared minus 6x minus 23 is equal to 0. Okay, so a quadratic, ax squared plus bx plus c. Okay, so if I think about the different ways I can solve a quadratic, it could be factorization like that, or it could be the minus b formula. That would work, and there's other ways. But this part here, give my answer in the form a plus or minus b root 2, to me hints actually factorization is not going to work. There's going to be no factors of 23, no whole numbers, factors of 23 that's going to give me minus 6. Well, that's exactly what's going to happen, because if I look at the factors of 23, that's what we call a prime number. It has only two factors, itself and 1. None of them, I can't add either of them together to give me the minus 6, okay? So it doesn't mean there's no solutions, it just means the solutions are decimal point answers. So example, 4 5s are 20, so 4 point something by 5 point something will give me minus 23, for example. So it's a minus b formula one. Let me just find that in the log tables. So there's an algebra page in the log tables on page 20. You can see as long as the equation is in the form ax squared plus bx plus c, I can use the minus b formula. Okay, so x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So remember, we said any quadratic is ax squared plus bx plus c is equal to 0. I have x squared minus 6x minus 23 equal to 0. Okay, so my a is the number in front of x squared. So for me, my a is 1. B is the number in front of x, so my b, and you have to take the sign, b is minus 6. And c in is the number on its own, which is minus 23. So I tend not to look at the quadratic anymore. I literally just look here, because no x's goes into the minus b formula. It is just what we call the coefficients, which are the numbers in front of the x squareds and so on. So minus b, so I have minus 6 plus or minus the square root of minus 6 squared minus 4 by a by c all over 2a, which is 2 times 1. So minus 6 is 6, plus or minus, and then into my calculator I'm putting the square root of bracket minus 6, close my bracket, squared. The minus 6 has to go into a bracket so that the minus gets squared as well. Okay, minus 4ac, and for that I'm getting 8 root 2 all over 2. Okay, so my first solution is 6 plus 8 root 2 over 2. And my second solution, 6 minus 8 root 2 over 2. Okay, and these questions that have square root signs in them, they're called surds. They're just a different way of writing a number. Don't let them bother you. Just proceed as normal as if it was an integer. Okay, your calculator is going to sort it out for you. You don't need to. Okay, so I get 3 plus 4 root 2. For anyone who is interested though, what ends up happening when you divide by 2 is 6 gets divided by 2 and you get 3. And also 8 gets divided by 2 and that's where I get 4. Okay, so in the same way, this one is going to be 3 minus 4 root 2. Okay, so my answers are in the form a plus or minus b root 2. Okay, what you have to be careful of here is that a and b you don't confuse with this a and b. Okay, when they use letters, they just stand in for a number. Okay, and they can use it to mean like in here, it's two different A and Bs, and you just have to be, I suppose, keep track of what you're doing. So our A's in this case are 3, our B's are 4, and it's root 2's. Okay, so I can say x is equal to, so just in case you see it written down anywhere, x is equal to 3 plus 4 root 2, and x is equal to 3 minus 4 root 2. It is also the same thing to write it as 3 plus or minus 4 root 2. You could also write your answer like that. Okay, so either or, either of these would be correct. So that was part A. Okay, so the minus b formula, so make sure you know it. Okay, B, solve the simultaneous equations. 2r minus s is equal to 10 and rs minus s squared is equal to 12. So we did some of these earlier in the week. So this is, I suppose, another example of one, and possibly a harder one at this stage. Okay, so most of the ones we've done up till now are x and y. The letters don't matter. The method is the same. So if you remember what we've done, we took the linear equation and we write it in terms of a letter. Okay, so I think it was the 2017 one we explained in good detail. So in this one, we would say 2r minus s is 10. I'm going to write it in terms of s. I don't want minus s, I want s. Okay, so a common mistake that's made is that that minus gets lost when you're writing it in terms of x. So you bring over the 2r, all right, and it becomes minus 2r, but you don't have the minus here, so that ends up being your answer. So that's a very common mistake that's made, but no, you have to take that s term is a minus term, so you have to take it. And it doesn't matter whether you have minus 10 plus 2r or 2r minus 10, that's the same thing. Okay, and what do we do with that s? Well, anywhere there was s in my equation, I have to sub it in. I have to sub in 2r minus 10 instead. Okay, so that second equation then becomes, well, we're going to sub it into rs minus s squared equals to 12. It's going to be r times 2r minus 10 minus 2r minus 10 all to be squared is equal to 12. Okay, and you know you've caught all the s's if you look across here and you don't see any of the s's, you just see the r letters. Okay, so then let's multiply 2r by r is 2r squared. 10 by r is 10r. And then minus, okay, we have to be really careful here because I have to square this bit first. So 2r minus 10 by 2r minus 10. 2r by 2r is 4r squared. 2r by minus 10 is minus 10, it's not, it's minus 20r. Minus 10 by 2r is minus 20r plus 100. And then, of course, that's equal to 12. Okay, so why did I put these big square brackets in it? Well, again, it's because of this minus that comes before it. So that minus changes the signs of everything here. And again, that's quite a common mistake that people put down. They would have something like minus 4r squared, but then they would forget to change the signs all the way across, okay? And the reason you have to change the signs all the way across is because it was minus s squared. And this is s squared. The whole thing is s squared. So that minus then has to be applied to it all. So what does that do? What will that look like? Well, I'll have 2r squared minus 10r. And then I'll have minus 4r squared. It changes the signs of everything across. I'll have minus 20r, which is plus 20r. I'll have minus 20r again, which is another plus 20r. And then I'll have minus by the plus 100, which is minus 100. I'm going to bring that 12 over so that it becomes minus 12 equal to 0, because I can see a quadratic starting to form. Okay, and then let's tidy up. So our x squared terms, I am getting minus 2r squared. My r terms, or an r, I have 20 and 20 is 40r minus 10r is 30R. And then my numbers, I have minus 100 minus 12, so that's minus 112 equals 0. Okay, I'm going to change the signs all the way across because I'm too afraid that I'll drop minuses along the way, so I think it's easier to solve. Perfectly okay to swap the signs all the way across as long as everything changes sign. And the last thing I'm going to do, I'm wondering, will I divide across by 2? Because they're all even numbers, so I could do that. Okay, and then let's factorize. So I have R and R. 7/8 are 56. And they add together to give me minus 15. Okay, so just explain some of that a little bit. If it's okay with you, I'm going to rub out this part just to give us some space, okay? So what have I done there now? Where did I get my minus 7 and my minus 8? Well, I took 56. Okay, so to factorize, the R squared gets factorized and the factors go in here. 56 gets factorized and the results go in here. But there's loads of factors of 56, okay? For example, you have 2 times, what's that? 28 will give me 56, or I have minus 2 minus 28. I have 7/8 or 56. I have minus 7 minus 8. I have 56 itself and 1. Okay, and there are others, okay? So all of these satisfy the conditions of being factors of 56. So the right line you take are the ones that when you add them together gives you minus 15. And that is why I took the minus 7 and the minus 8. And they go in here. Okay, so let's continue from there. So I have R minus 7, R minus 8 is equal to 0, R is equal to 7, R is equal to 8. Okay, so there's my 2 R values. So now I need to sub in to find S. Okay, again, you can sub into any equation you want. The one you've written or you've changed around here will be the easiest one to write, to sub it into. So S is equal to 2R minus 10. So when R is equal to 7, S is equal to 2 times 7 minus 10. 2 7s are 14 minus 10 is 4. So I'm getting S is equal to 4 for that one. And then when R was equal to 8, S was equal to 2 times 8 minus 10. 2 8s are 16 minus 10 is 6. So I'm getting X is equal to 6 for that one.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in Electronics and Self-Driving Technologies, and from there to the Masters.
Check out the link below for more information.